Hi, this is Maggie. In this video we're going to look at some common loop patterns, including input validation, using a loop to sum values, and using loops to find a best fit value. We will look at some code examples from the text. The first is a program that simply obtains an input in the valid range from the user. This program requests an input and then tests if the input is outside of the valid range. In this example, the valid range is 2 to 360 inclusive. So an input outside of the valid range is either less than 2 or greater than 360. If the input is outside the valid range, the program requests the input again. Once the test fails, meaning the user has entered a valid input, execution proceeds below the input validation loop. The program merely demonstrates an input validation loop, so it doesn't do anything with the valid input once entered. When writing an input validation loop, you can obtain an input from the user and then test for an invalid value. If the value is invalid, we go into the loop and request another value. Remember that execution will always return from the end of the loop body back up to the loop entry condition. So the loop will always check the input after it's been entered. If we make it to the first line after the loop, that means the loop entry condition has failed. Because the loop entry condition tests for invalid input, that means the user has entered a valid value. To practice with this, look at different programming problems with different input requirements and write input validation loops for those programs. Remember that the loop entry condition describes bad input, and remember to obtain a new input inside the loop. The next program from the text is part of software written to support a library summer reading program. In the program, children record the minutes that they've read each week. This program obtains the names and minutes for 5 children. It sums the minutes read by all children, and it finds the maximum of the minutes values entered. If we run the program and enter the names of 5 children, and the minutes 10, 30, 50, 20, 40, you will see that it sums the minutes to 150, and it finds that the child who read for 50 minutes logged the largest minute value. The easiest way to understand this is to look at the way variables are used to solve these problems. First, we have a familiar variable, the loop control variable. That is num children and integer. And if you look at num children in our loop, you'll see that it follows the pattern for driving a loop to execute a specific number of times. It's initialized to 0 before the loop. The test for entering the loop is num children less than 5, and it is incremented by 1 at the end of the loop. That is our loop control variable, and it drives the loop to execute 5 times. Within the loop, we need variables to obtain the name and number of minutes. These variables will always hold the last name and minutes values entered by the user, so we call them most recent holders. They hold the most recent value entered. These are assigned the values of input statements at the top of the loop. We've seen variables to hold inputs before, but the difference with the role these variables play is they are given new values each time through the loop. So if we want to hold on to the minutes or the name, we need to do something with them before the new value replaces the current value the next time through the loop. What we're doing is finding the largest minutes and summing the minutes into a total. Let's look at the sum first, using a variable in an accumulator role. Our total minutes variable is given an initial value of 0. Each time through the loop, we add the new value of minutes, called num_minutes, to the value already in the sum. We are using the augmented assignment operator plus equals to do that. This assignment statement is a shorthand for total minutes equals total minutes plus num_minutes. So it adds the value that's already in total minutes to num_minutes and stores the result back in total minutes. This allows us to accumulate each new value entered by the user into our sum. The other variable role is a most wanted holder role, and that allows us to store the most recently entered value that is the best fit so far for some criteria. Our criteria is largest number of minutes read, but it could be a different criteria such as smallest, or, in a different context, something like largest odd number, largest number divisible by 10, etc. Our variable in the most wanted holder role is max minutes. Notice first that we initialize this to a very small number, a number smaller than the smallest number that will be entered. We want to start that value off as one that will be replaced inside the loop. Another strategy for giving the most wanted holder an initial value is to read in the first child's minutes before the loop and initialize the most wanted holder variable to that value. Inside the loop, we compare the most recently entered value, num_minutes, with the value we're holding on to as the best fit so far, max minutes, and if the new value is larger, we replace the value in max minutes. We're also going to hold on to the name of the child with the most minutes, so we replace the value in max name as well. This is so at the end of our program we can display the name of the child who read the most minutes. Imagine how these variables work as the program executes. The first time we entered the loop, we gave the name Josh and the minutes 10. The value 10 is compared to the value in max minutes, which is the value we placed there when we initialized the variable, -1. Because 10 is greater than -1, we execute the conditional code and replace the max minutes value with 10 and the max name value with Josh. We then add 10 into the total minutes value, which was 0. We increment the number of students and loop back up to the loop entry condition and enter the loop again. This time we entered Lizzie and 30. And because 30 is greater than 10, we replace our max minutes with 30 and our max name with Lizzie. We accumulate the 30 into our total, previously 10, to get 40. The loop proceeds in that way with each set of values we enter. 50 is larger than 30, so we'll replace our max values with 50 and Brian, and we'll add 50 to our total. But when we get to Sam and Sam's 20 minutes, that is less than 50, our current max, so no replacement happens. The 20 is added to the total. Sarah's 40 minutes also isn't larger than 50, so it's added to the total, but again, doesn't replace the max. We'll look at a variation of this loop. Suppose we want to be flexible about the amount of data entered. We don't want to loop 5 times, we want to loop until the user is finished entering values. But how do we know when the user is finished? We can write a sentinel-controlled loop, which is a loop that allows the user to enter a value or, instead of a value, a sentinel value that tells us they're done entering values. The sentinel value, because it's being entered in the input stream, has to be a value that wouldn't naturally appear in the input stream. Because it's unlikely a child's name would be the word quit, we make that the sentinel value. If I run the program, you can see the prompt now instructs us to enter a child's name or the word quit. Looking at the code, the loop executes while the name isn't quit. It's also structured slightly differently inside. We get the name before we go into the loop to handle the case in which the user enters quit right away. Once we're in the loop, we know the user didn't enter quit, so we can get the minutes, add it to our total, and compare to our max. We then get another name again at the bottom of the loop. Because it's a loop, it will go back up to the loop entry condition and test it. If the user entered a name, then we'll go back into the loop, get the minutes, and compare and accumulate. But if they entered quit, then the loop entry condition will fail, and we'll go to the part of the program that displays the summary information. These are loop patterns that you should practice with. Start by writing the loops from this video without looking at the video or the text, and then write some variations. Can you find the smallest number of minutes read? Can you find the average of minutes read in the sentinel loop? Try writing a sentinel-controlled loop that uses the minutes as the input stream with the sentinel value rather than the name. And then maybe think up some accumulator, most wanted, and sentinel loops of your own. Once you can write these variations, you're ready to move on.